Hey guys, so today we're going to look at graphing piecewise functions. And a piecewise function is just a function defined by at least two equations, where each of those equations applies to a different part of the domain. Their pieces may be all linear or a combination of the different forms of functions that we looked at, such as linear, quadratic, cubic, square root, exponential, or even absolute value. So f of x is the entire function that we're graphing, and we're looking at two different pieces. We're looking at this linear equation, 2x plus 4. So when y equals 2x plus 4, and we're also looking at when y equals negative x plus 2. And we're only graphing 2x plus 4 when our x values are greater than 1. So we look at the restricted domain here, that x is greater than 1. We're only graphing a piece of that line, and that piece of the line is when our x values are greater than 1. So we need to use that number and include that number in our table. So now when we think of numbers that are greater than 1, we think of 2, 3, 4, 5, etc. So from here, we're going to go to our calculator, type in 2x plus 4, and pull up the table. And we're just going to copy down our values from when x is 1 and then numbers in the x columns that were greater that we wrote in our table. So when x was 1, we had y equals 6, 8, we had a 10, a 12, and 14. We can't really graph 5, 14 or the 4, 12 in our graph, so these 3 points will do. So before we start graphing, we have to look at our symbols. So for here, they gave us the greater than symbol, which does not state greater than or equal to, so that's going to be an open circle. So at 1, 6, we're going to put an open circle. Then 2, 8, and then 3, 10. So when we connect this to form a line, we cannot put an arrow on 1, 6 because the domain says we're only graphing a piece of this equation, and that piece only exists when our x values are greater than 1. So no arrow on 1, 6, but the point 3, 10, we can extend that with an arrow because our graph can continue. Our x values greater than 1, if our graph was big enough, would be able to be graphed. Now we're going to do the same thing for the second part, which is negative x plus 2. So from here, it's saying we could only graph a piece of this equation when the x values are less than or equal to 1. So that equation only exists when x is less than or equal to 1. So I need to include that 1 in my table. And from here, let's think of x values that are less than 1, which is 0, negative 1, negative 2, and negative 3. So from here, I'm going to type into my calculator negative x plus 2 and pull up the table. And we need that point of 1, like that's our go-to point, the one that we're focusing in on. And we're going to copy down those values. So we had a 1, a 2, 3, 4, and 5, I believe. Yes. Okay, so let's look at this point. When x equals 1 for this one, it said less than or equal to, which means we're going to use a closed circle. So 1, 1 becomes closed, 0, 2, negative 1, 3, and so forth. We can continue on with this pattern and copying the values down in our table, or you should notice that it's going up one, left one, up one, left one. So we can just create a straight line. So again, we're going to put the arrow after this point because our domain says when our x values are less than or equal to 1. So we can continue to graph all of those points to make a true statement, but we cannot put an arrow on this starting point of 1, 1, because if I put an arrow here, that means my x values are now greater than 1, but my domain up here says they cannot be. So that should have no arrow. Okay, so now let's look at evaluating on the bottom. So this is saying find y when x equals -2. Now we have to look at where does -2 fall in? It's in the purple side of the function. So when x is -2, our y value is 1, 2, 3. This is saying when x equals 1. So now I'm going to go over to when x equals 1, and I'm going to scan up and down. You should notice right here, as I scan up and down, I'm going to have 2 values. But I should know that this open circle is not included, but the closed circle is included. So a closed circle overrules that open circle. So when x equals 1, I only have one answer of 1. Let me just get rid of this. Okay, and then the next part says when x equals 3. So when x equals 3, 1, 2, 3, when I scan up or down, my y value is going to be a 10. So a few things before we move on. You should notice that in our graph, we need an open and closed circle because of the symbols here in the restricted domain. And you should also notice I did not label my blue equation with 2x plus 4 and my purple equation with -x plus 2. With a piecewise function, we do not want to label each component or each piece of the graph because the entire function f of x right here, this entire function f of x is made up of that entire graph that you're looking at. Okay, so for the second example, you should notice that this piecewise function exists with a linear function and a quadratic. The previous example was just linear. So let's break up the first part. So we have the equation y equals 2x plus 7, and that equation only exists when the x values are less than -3. So I'm going to put -3 as my starting x value in the table that I'm looking at. So think of numbers that are less than -3. So we have -3, -4, -5, -6, -7. So once we have those numbers, I'm going to pull up my table in the calculator. So go to y equals 2x plus 7. And I'm going to focus in on -3 all the way to -7. I can continue up and graph to -8 since that fits on the graph, but once we graph a few points, you'll see the pattern and you continue on. So when x is -3, we had 1, -1, -3, -5, -7. And if you want to include -8, -9, that's fine. So let's focus in on the symbol, which is a less than symbol, which means we want to use an open circle. So -3, 1, 2, 3, up 1, we put an open circle, -4, -1, -5, -3, And we're going to keep going until we hit the end of the graph. So where that open circle exists, we cannot put an arrow, but we're going to connect everything with a straight line and put an arrow on the other end, because again, it's saying we're only graphing a piece of that function when x is less than -3. So now let's look at the second component. We have x squared plus 4x plus 3, and we are graphing that quadratic when x is greater than or equal to -3. So I'm just going to put a closed circle next to that point, knowing that I have to use a closed circle because of this symbol right here. With a line underneath, we fill in the circle because it's included. And we are used to, with a quadratic, looking for that pattern with the turning point. So typically we would scroll through here and use these values here because we see the turning point and the points or the patterns above and below. But again, they are telling you to only use when x is greater than -3. So we're going to take this value when x is -3. Oops, wrote the wrong number. Sorry guys, I noticed I typed in the equation wrong, and now that I fixed it. So when x is -3, and then our numbers that are greater than -3 in the x column. So we're going to do -3 and 0, -2, -1, -1, 0, 0, 1, 3 it was, 1, 8, 2, 15. Again, you can't even fit that one on your graph, so we're going to exclude it in our table. So now we're going to start graphing that -3, comma 0. That's a closed circle. -2, -1, -1, 0, 0, 3, 1, comma 8. We are not going to put arrows on the -3, 0 side, but we can continue with an arrow here. Make sure, because this is a quadratic, that this is scooped below. Remember, it should be a curved pattern through the turning point. And I did realize that I graphed this one wrong. I was off by a point. -3 ones here. I'm sorry, guys. Okay, so again, do not label each component. The whole entire graph f of x consists of those pieces of the graph. So this is saying when x equals -3. So when x equals -3, 1, 2, 3, we're going to -3. We scan up and down. But when I go up, I should see an open circle, so that will not yield an answer. But when I go down, I see a closed circle. So when x equals -3, the only y value that exists is 0. When x equals 0, I'm scanning to x equals 0. I go up and down. I notice that my y value is 3. And when x is 1, I go to x equals 1, scan up and down, and I'll notice my y value is 8. And then for the last example, this is saying the equation y equals 3. And we're only graphing y equals 3 when our x values are greater than -1. So numbers that are greater than -1 are 0, 1, 2, and 3, etc. When I go to my graph and type in y equals 3, you should notice that every single y value will be a 3. So the easiest way to graph this is go to that point, -1, comma 3. Make sure you're using an open circle. And then just create a straight line. You don't have to make the individual dots here, but if you want to, you can. And then for the last part of the line, right here, we're looking at -x plus 2, and we're only graphing that when your x values are less than or equal to -1. And we're going to use a closed circle here. When I pull up my table, I have a 3, 4, 5, and 6. And when I